Welcome to this class on color and light theory. When drawing or painting, black and white can only take you so far. It's really with colors and light that you'll be able to bring your artworks to life. We'll start by looking at the three main properties of colors, including values, hues, and saturation. Next, I'll introduce lights and shadows to the mix, which is really what is going to allow us to perceive colors in the first place, understand how colors appear to change based on their environment, and is usually what will give to the shapes their third dimension. This is the first of two classes on color and light, so we'll keep things relatively simple, but we'll also learn to create simple color palettes so that you can start to experiment on your own the right way. Understanding colors is essential for artists and something that you'll be using for your entire artist's life, whether you're planning to be an illustrator, graphic designer, concept artist, matte painter, comic artist, whatever it may be. Colors are not only important based on how often you'll have to work with them, but they will also often make or break an artwork. So before we dive into the various properties, let's take a look at a few basics that you should definitely know before we can understand the rest of the class. As we've seen previously, the inner surfaces of your eye, or the retina, contain photoreceptors. Those are specialized cells that are sensitive to light and relay messages to your brain. There are two types of photoreceptors: cones, which are sensitive to color, and rods, which are more sensitive to intensity. You're able to see an object when light from the object enters your eye and strikes these photoreceptors. Some objects are luminous and give off their own light, but all other objects can only be seen if they reflect light into your eyes. However, humans can only see visible lights, a narrow band of the electromagnetic spectrum, which also includes non-visible radio waves, infrared light, ultraviolet lights, X-rays, and gamma rays. So only a very small portion of that entire spectrum. In terms of wavelengths, the visible light ranges from about 400 nanometers to 700 nanometers. Different wavelengths of light are perceived as different colors. For example, light with a wavelength of about 400 nanometers is seen as violet, and light with a wavelength of 700 is seen as red. However, it is not typical to see light of a single wavelength. So you're able to see and perceive all colors because there are three sets of cones in your eyes. One set that is most sensitive to wavelength corresponding to red light, another that is more sensitive to green light, and a third that is more sensitive to blue light. This is where color can get a little confusing for some people. There are two basic color models that you need to learn if you ever want to master colors. These two models are light color primaries and pigment color primaries. So for light color primaries, this is very much what we are going to use and what's going to be relevant for us digital artists, because it's the red, green, and blue channel, and those essentially what make up the pixels that you're seeing on the screen. And then there's also the pigment color primaries, and those are going to be for print media. So cyan, magenta, yellow. You can probably remember that those are the colors that you'll find in your printers, on top of black, of course, but those are going to be, for anything that's physical, where the light from the sun or from a light source in your house or wherever you are is bouncing off of the surface that you're looking at and then into your eyes, as opposed to the screen where it's actually shooting the light directly into your eye. It doesn't need to bounce it off of anything. Now, if you've ever looked into colors a little bit, you might be wondering, why aren't we talking about the blue, red, and yellow model? And isn't that what the pigment color primaries model should be? Well, the reality is that yes, a lot of school will teach red, blue, red, and yellow, and this is also what a lot of painter will use as their primary colors when it comes to mixing the colors. But the reality is just that it's an older model that doesn't really accurately or scientifically address the true range of spectral colors. So, there's a bunch of discoveries that were made ever since the original model using blue, red, and yellow came out. And now what actually works best for the human eye is the, what printers use essentially now. But indeed, if we when we look at the color wheel, or if you ever buy or create a color wheel, it's going to be based off of the red, blue, and yellow model, because this is what is going to typically be in stores still. And most of the books, most of the art books also use that model. So now to dive in a little bit more and look at those two different models, let's start with additive colors. So this is going to be always based off of light. So red, green, and blue, those are the primary colors of light. They can be combined in different proportions to make all other colors. For example, red light and green light added together are seen as yellow light. This additive color system is used by light sources such as televisions, computer monitors, like I've just mentioned, to create a wide range of colors. And when different proportions of red, green, and blue light enter your eye, your brain is able to interpret the different combinations as different colors. Equal amounts of red, green, and blue light creates white lights. Now, this is going to be in contrast with subtractive colors, which is the other method, the other model. And this is going to be based off of real paint. The primary colors of pigments are magenta, yellow, and cyan, but this is also commonly simplified as red, yellow, and blue by painters. Pigments are chemicals that absorb selective wavelength and that prevent certain wavelength of light from being transmitted or reflected. Because paints contain pigments, when white light, which is composed of red, green, and blue light, as we remember, shines on colored paint, only some of the wavelength of light are reflected. For example, cyan paint absorbs red light but reflects blue and green light. Yellow paint absorbs blue light but reflects red and green light. If cyan paint is mixed with yellow paint, you see green paint because both red and blue light are absorbed and only green light is reflected. So to recap, when paints are mixed, the colors absorb every color except the wavelength that we see reflected back. The more color that you add together, so mixing more and more different paint colors will result in darker and darker colors, all the way to black as more frequencies are absorbed. So there we go. As artists, it's very important that we know the difference between additive and subtractive colors. The name itself kind of makes it easy to understand and to remember. So additive color, again, this is going to be based off of light, and the more you add together, the more wavelength that you add together, the brighter the result will be, and the closer to white you will go, as opposed to subtractive colors, where it's the complete opposite. And the more paint of different colors that you mix together, the closer the result will seem black, or will appear black to us. So for us as artists, obviously the one we'll use the most is going to be the additive color model, and that includes all three light color primaries, which is red, green, and blue, or RGB. In this chapter, we'll take a look at the three properties of colors I briefly mentioned in the first chapter. So in order of importance, those are hues, values, and saturation. And so very similar to the elements of art that we covered in the visual communication class, these properties are going to be the main tools that we have at our disposition when working with colors. So you can think of them as different parameters that we'll be able to play around with to essentially be able to generate all the colors that exist. Now, before we take a look at all the properties in more detail, let's take a look at the different color models and their associated color wheels. So really quickly, starting from the left here, we have the red, yellow, and blue model. So this one is going to be the one used by most traditional painters. This is the older model that's been around for hundreds of years now, and it's not as accurate scientifically, but it's still going to be the one that's probably found in the majority of art books, and the one that a lot of art schools, fine art schools, still teach. And so just because it's still around, it's important that we know what this is all about. And so, when buying an art book, for example, learning how to paint and things like that, those are probably the colors that you'll be working with. Now, on the center here, on the other hand, we have the updated model. So as you can see, they're pretty similar. Those two models are going to be the ones that are pigment based. So ink or paint, and those are going to be the ones, this model here is going to be the one for modern day printers, and so it's going to be the cyan, magenta, and yellow model, and the K stands for black, so cyan, magenta, yellow, and black. Now on the far right here we have the one that is most relevant to us, the RGB model, which is going to be based off of light instead. So this one is, in a way, the colors here are in a way a lot more pure, because there's no relying on pigments, on physical pigments. There's no relying on physical surfaces or anything like that. It's a much more direct way to interact with the colors. It starts right from the computer screen directly into our eyes. So yeah, they will appear a lot more pure than the other two here, the other two models that are based off of pigments. And the main reason really is just the surface that that those colors have to be painted on. The only way to really interact with those colors is to see them on a surface and have light essentially reflect off of that surface and then into our eyes, and this is how we're able to see them. But no surface is perfect, which is why those colors are never going to be as pure, never appear to be as pure as their counterparts in the light-based model for RGB. But now looking at the actual color wheel here to understand what's in the center here. So the center, the three colors in the center, forming this big triangle, those are going to be the primary colors for any of those particular models. As you can see here, it changes a little bit, but so in the center here for the CMYK model, we'll have the yellow, the magenta, and the cyan, and those are going to be the three primary colors. They're also represented here on the color wheel itself. And then the triangles here on the outside, this is going to be the secondary colors. So it's what happens when you mix two of the primary colors together, you'll get this color instead. And so if you mix yellow and magenta, well, you get red. And then we still have another set of colors, which is going to be the tertiary colors. So it's essentially a mix of color between a primary color and a secondary color. So in this case, if you mix yellow, a primary color, with red, a secondary color, you get orange, a tertiary color. Now, the same applies on all the different color wheels. It's just, the colors themselves are going to be slightly different. And like we've seen before, mixing those paints here, those pigment-based colors, well, the resulting color is always going to be a little bit darker. So as you can see here, you're mixing a bright yellow with a bright magenta. It turns into a slightly darker red. It's even more apparent here when you mix the blue and magenta together. It gives this darker color here, this darker blue color. And so this is going to be the main difference here when talking about pigments. The more you mix together, the darker they become. But it's also probably important that we mention the little K here found in the CMYK model. And the K, like we've seen, it stands for black. And this is a necessity. It's important that we add it, and we should probably add it to this model as well. This is just because it's impossible to get a pure black by mixing all of these colors together, or by mixing all the primary colors together. So you'll get at best a dark gray, a really dark gray, but you'll never be able to get a pure black. And that just has to do with the physical properties of those colors here. So they're always going to be, painted or printed on a surface. And that surface is never going to be perfect, whether it's paper, wood, or whatever it is. There's always going to be some slight imperfections on the surface itself. It is always going to be some sort of imperfections in the ink or in the paint itself. So whether it's the oil that is used, maybe it's not completely transparent, or maybe the pigments themselves are not, the top quality. Even if they're the best quality, the way that the paint will dry is not going to be a smooth, perfect surface that is going to reflect light, perfectly. There's always going to be some sort of imperfections at some point, and so as a result, you'll never be able to get a pure black, which is why we need to add it. And obviously, this is going to be in contrast with the light-based model RGB, because a black is simply, in that case, an absence of light. So if you switch off a pixel, if you switch off your computer screen, you have black because there's no light being emitted from the device. And so now that we are aware of the difference between the different color models, let's take a look at the first color properties, the most important of them all, hue. So I consider the hue the most important property because that is really what most people will refer to when describing a color. So if you describe the color yellow, for example, or if you talk about a red color, you're really going to be describing the red hue of that color, not so much the saturation of the color, not so much the value of that color. So the hue really is going to be the colors in their purest form. So if you buy a tube of yellow paint, for example, it's going to be the paint as it comes out of the tube without any added black or added white to it. And in the case of the light primary, so the light model, well, this is going to be a little bit different, but essentially the hue of the color is going to represent a particular wavelength. So, if you think of a red color, for example, well, the red is going to be associated with a 700 or something like that, 700 nanometer wavelength. And that wavelength itself is going to dictate the hue of the color. Now, if we open the Photoshop color picker or, whatever software you're using, you'll probably find something like this. There's a bunch of different variants to this, but really this one represents all the different properties really well, so I really like this one to explain it. And in this case here, well, the hues are going to be this band in the center here. So all of these colors in the center, when you drag this up and down, you're going to be selecting the hue of the color and nothing else. And so this band really is a color wheel just straightened out. And to prove that, you can see here the number changes here, and it's a number that's in degrees, right? And H here, so this is H for hue. So as the hue changes, the degree also changes, and it's going to be 360 degrees. So in this case, when dragging the slider up and down, each of those degrees here are going to be associated with one particular color or one particular wavelength, which is going to in turn be represented by a color. And so this is really what you're choosing here. So that's pretty much it for the hue. It's the purest form of any color. So this brings us to the second property, which is going to be the value of a color. So the value really is going to be referring to the lightness or the darkness of a color. It really indicates the quantity of light that is reflected for pigment colors. And for the light primaries, well, this is going to be the amount of brightness. So value is interesting in the sense that it's pretty much independent of the colors themselves. So it's very, very simple in a sense. It's a range going from pure brightness, so full white, to full black. And so this is going to be the range that we see here on the far left of the color picker. It's just different shades of grays and pure black and pure white. And in this case here in Photoshop, you can see that being represented here in the little B here. If I look at the percentage of the B here, which B stands for brightness, you can see that change as I slide it down or up. So when it's completely white here, it's at 100% brightness. And if I slide it all the way down here, it's at 0% brightness, so it's completely black. So when talking about photos or paintings that have a good range of values, this is going to be referring to exactly that. So if a photo has a nice range of values, it's often referring to the fact that it's going to have pure black, then a lot of different grays in between, and possibly also pure white in it. So you'll have the entire range going from 0% brightness to 100% brightness, and kind of a lot of the different shades of gray in between. A painting or a photo that has a limited value range, in this case, well, it might instead go from here to here, and that's it, right? So it might instead go from something like, just completely random numbers, but something like 25% brightness all the way up to maybe 70% brightness. So that would be a photo or a painting with a limited value range. And this is often like a style choice. So sometimes painters will like to have a limited range of values to play with, and this forces them to rely on other properties of the colors to create some interesting things. So there's no right or wrong way in that sense, but yeah, when it comes to the value, it's really, that's all it is. It's the brightness of a color. And when you mix that with the hue of a color, then you're already able to have some really, really interesting results. So when it comes to pigments, for example, that would be the same as adding black to the paint. So let's say you have, again, a yellow paint that you put on your palette, and the more black you add to it, the lower the value of your color is going to be. So the more it goes towards the black, the darker the value of the color and the more pure it is. So if you don't add anything to your color, to your paint, then it's going to be full brightness and full value, 100% brightness. In the case of the light model, so for RGB, this is going to be a little bit different, but essentially it's represented only as brightness. So it's the brightness of the light, right? So if there's no brightness at all, then it's completely black. There's no image. There's nothing. We're not going to be able to see any color. But if it's at full brightness, then we'll see the color as we see them right here on the color wheel. Those are all at 100%, as you can see here. You know, as I drag them, as I color pick them, you can see the little selector here is always going to stay at the very top, meaning it has 100% brightness. And you can also confirm that by just looking at the brightness number here. It stays at 100% regardless of the color that I'm color picking. So then finally, this brings us to the last property of color, which is going to be the saturation. So in this case here, it's going to be represented by the S that you can see here. So again, I'm at 100% saturation here. And really the saturation is going to be, you know, we've seen this is the hue right here from the top, from the bottom to the top. This is going to be the values, and then saturation really is going to be from the left to the right. So this is going to be the intensity of the color, and it's also referred to as a chroma. So it refers to the dominance of hue in the color. So then when talking about pigments, again, in that case, the equivalent would be to add white to your color. So instead of adding black, you would add white to the color, and that would change the saturation of the color. And of course, you can add black on top of that to change the value as well. But by adding white to a color, to a pure color, a pure pigment, well, you will desaturate that color as a result. And then when talking about the light model, so the RGB model, well, it's really going to be the intensity of the hue. So if the hue is really, really intense, if it's at its maximum, then we'll have maximum saturation. And as the hue becomes less and less intense, less and less dominant, then this is what we will call a lower and lower saturation. So now when talking about saturation, there's a couple more terms that a lot of people will use, especially when it comes to the pigment-based colors. So it's going to have to do with this little thing here. So the top portion here, this is going to be for pigment colors, pigment-based colors. And this, on the other hand, is going to be a little bit less important, but it's going to be based on HSB, hue, saturation, brightness. And this model is actually the same as you can see here. So HSB, hue, saturation, brightness. So this is going to be the digital version of the same thing, really, but as you can see, it's super simple in comparison. So really, what we're looking at here at the top is going to be those three terms. So tint, tone, and shade. And really, this is going to be more for photography or traditional painting or print. And those three terms are going to refer to the tint is going to be the saturation, the tone is going to be a mix of the saturation and the brightness, and the shade is going to be solely about the brightness or the value of a color. And so what we have here at the top is if we take a hue like this, so a pure color, let's go with the same red, and then we add white to it, essentially we'll be changing the tint of that color. So the tint of that color is going to be just the saturation. We're not going to be changing the value of the color. We're not going to be able to change of course, we're not changing the hue of the color. It's really just the saturation. I can prove this by color picking this here. So if we look at the saturation here, this is the only thing that will change. The brightness here will stay at 100%. So if I go click here, saturation at 100 when I click on the most saturated part of that red. And if I slide to the right here, you can see the saturation go down and down and down and down and down until it hits 0%, but still the brightness was at 100. So we're really just talking about the saturation when playing around with the tint. The tone then is going to be a mix of the two. So if we start again with a pure red, and then we add some mid-level gray. So as you can see here, I'm going to pick all the way on the left, make sure that I have brightness at 50%. I mean, the number really doesn't matter, but in this case, it's a perfectly mid-gray. So the perfect spot right in between a full white and a full black. And if I add that to the mix, then I'll be changing the tone of that color instead, not the tint. And the tone of the color, well, it's two different things. It's the brightness and the saturation, as we are about to see right now. So if we do the same exercise here, and I start from the fully saturated color, fully saturated red, start here, and if we look at the saturation and the brightness, in theory, the brightness should go down all the way to 50%, and the saturation should go down all the way to 0. So slide, 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 and there we go. So 50% gray, what I started with. And as you can see here, down, the saturation is down to 0. But the value changed as well since I was using a gray. So if I'm using a really, really dark gray, then I'll get the same result. And the brightness will go down all the way to the lowest brightness that I've selected for that gray. Now, if we do the last one here, again, start with pure red. And add some black to it, some pure black. Make sure it's all the way down, 0%. If I add black to that, then we're not going to be changing the saturation. And this is maybe a little bit strange to hear, but by adding black, you're not changing the saturation at all of the color. You're just changing the value of it. I'll try to get a nice gradient here to pure black, and then we'll do the same thing again, color pick this, and as you can see, the only thing that will change is going to be the value. So I'll start at full brightness, full value here, all the way to the top, and you'll see that thing go down, 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 as the saturation remains the same, but as the brightness starts to go down. And when I do this, I'll be changing the shade of that color. Of course, when it gets to pure black, then there's no saturation whatsoever. But as long as it's not completely pure black, right? So as long as it's a shade of gray, like it is right here, even if it's 1% brightness, as long as there's a little bit of brightness left, the saturation will remain at 100%. So there we go. So those are the main difference. So when talking about tint, we're really talking about saturation. When talking about shade, we're really talking about just the values of the color. And the tone is kind of the one in between, the one that is a little bit misused often, and that is going to refer to both, right? So it's going to be the saturation and the value of the color that you'll be changing. So then for the HSB model here, things are going to be a little bit different. It's actually going to be the opposite. So instead of adding black, instead of adding gray, instead of adding white, we're essentially just removing things when it comes to light, right? So I start at 100% everything, so 100% saturation, 100% brightness, and then if I want to change the shade, for example, of that color, well, all I have to do is reduce the brightness. So I can just start to go down, down, and down, and now I'm changing the shade by simply removing brightness. And if I want to change the tint, what I can do is simply removing the intensity of the hue, and so the saturation goes down. And if I want to change the tone, well, all I have to do is kind of go in between, right? So not stick to that side, not stick to the top, and instead go kind of like anywhere in between. And as a result, the saturation and the brightness will change, and then I'll be changing the tone of it. So it's kind of the other way around. I mean, the same terms can be used. It's just a different way to talk about the exact same thing. Now, really quickly, before we end the chapter, I wanted to come back here to this example and see what those colors look like once they're mixed. So there's not going to be much to say about these two here for the pigments, color pigments, but you know, it's especially not that great of a result because it's Photoshop doing the mixing, and Photoshop is not exactly like real paint, so it doesn't behave the same way, and I couldn't find blending mode that represented or that mimicked real life, but it's kind of close, and it gets the point across where the the mix of all of these colors is a darker color, and that is not a pure black, right? So if we look at this color here, it's still 17% brightness, and if we look at this one right here, which is a little bit closer to reality, it's still 9% brightness, so it's not a pure black. So this one here, not so accurate, but for the CMYK model, I've made sure that those colors are actually the ones that would get printed, that would be output by Photoshop. So this is a little bit closer to reality, but it all goes to show that even though they are all combined and they should be black, the final result is not black. So which is why you need the little K, which is why you need the added pure black when it comes to pigment, or the colors of pigments. Now, if we take a look at the RGB model, things get a little bit more interesting. So if I look at just the red, for example, and take a look at the brightness here, it's already at 100%. And so all the primary colors are already at 100%. So the secondary colors are also, and then the white is also. So how do we explain the obvious difference in brightness when you look at the white here and the red? Or even, if you mix the red and the green, it gives off this yellow color, which is, if you look at the yellow and the red, there's a clear difference, right? In perceived brightness. The yellow appears to be a lot brighter, even though Photoshop tells me that it isn't. And the way to look at this is that each of these individual hues, so this hue, this hue, this hue, individually on their own, they're at 100%. They can't get any brighter than that color, otherwise they're going to turn into a different color. So that green can't get any more green. You can't make that green be any purer than that. It's as bright as it will get. But for us artists, that doesn't really make any sense. So for it to be a little bit more meaningful, we have to look at the RGB down here. So those values are going to be a little bit more indicative of the actual perceived amount of brightness that we can see. So these values go from 0 to 255. 255 is just it's a mathematical thing. This represents 8 bits, and each channel is 8 bits. Anyways, we're not going to get into that. It really doesn't matter. Just consider 255 the maximum, or 100%. And so if I click on red, for example, all the other, the green channel and the blue channel are turned off. Only the red is at 100%. Same thing here if I click on the blue, and same thing here if I click on the green. So the best way to look at this then is going to be each of these boxes here, consider those like flashlights. So if one flashlight is turned on out of 3 that emit the same amount of light, right? So one flashlight will emit a green light, another one will emit red light, and the other one's going to be a blue light. So those 3 flashlights on their own, they can't get any brighter. But if you have one flashlight turned on and the other 2 are turned off, you'll get some light out there. But then if you turn on all the flashlights at the same time, you'll get more light because there's just more light particles coming out. And this is kind of how we explain the apparent, higher brightness for the secondary colors, and then even brighter for the white here, where all the colors are mixed together. And so you can look at those numbers and use those as an indication of how bright something is going to be. So if you look at this in here, only have 250 points, right? So 255 points, that's not bad. But then if I click on the yellow here, oh, the yellow now has double that. So it's what, 510 points now. So 510 points is more than 255. It's double, so it's double the brightness. It's not exactly double the brightness, but And then the same goes with the white here. So now it's even more points, meaning it's even brighter, or at least it appears brighter. So the more you have, if you add all these 3 numbers, the higher the total, the brighter the color will appear to be. And this is really, I've been comparing this to flashlights. That's actually how it works with the pixels on the screen. So each pixel is like 3 different flashlights, kind of. So one flashlight is going to be red, another one blue, another one green. And so, if we look at the red color here on the screen, to be able to see this red color, it means only 1/3 of the pixel is lit up. The other 2/3 of the pixel are turned off, meaning you only have 1/3 of the light really coming through for all of these pixels. So as you can see here now, if I turn on another third of the pixels, if I turn on the green portion of the pixel, now 2/3 of the pixel is on and there's only 1/3 that is off. And so it's going to be significantly brighter, obviously, as we can see here with the yellow. And then if we turn on the last third part of the pixel, then the entire three portions of the pixels are turned on, and as a result we get the brightest perceived color, because we get as much light as we possibly can. So there you go. Even though Photoshop might be telling us that each of these colors are in fact at 100%, which they are, in terms of perceived light, we have to look at the amount here, the amount of flashlights that are open and how much those flashlights are open. So of course, right now we're just looking at 0 and 255, but we can get any number in between, of course. And so it's the total of these three numbers added together should give us a better idea of the total brightness, right? So the entire range should be from 0 for black all the way up to 255. So that's what, 765? Yeah. So then we can pick any color now. And let's say we pick this color here and we add those three numbers, and this should give us a total. And then we can see, how close is this total to the top? How close is that total to 765, which is going to be the brightest color? Or how close is it to 0, which is going to be the darkest color? And so this is kind of how we can understand the perceived brightness a little bit better. It's a little bit more useful than looking at the percentage here for the actual brightness for each of those colors. And this is going to be pretty much it for this chapter. So in the next chapter, we'll take a look at lights and shadows. I'll see you in a bit. Now that we have a pretty good understanding of the different properties of colors, we should probably take a look at the one thing that is going to have the biggest impact on color of all, and that is going to be light itself. So when it comes to light, it's going to affect the values of the colors the most, and then it will affect the saturation to some degrees, and it will also affect the hues depending on the color of the light. So it is going to really affect a lot of things, and it's one of the most important aspects of any painting. Light is such a key for so many things, and we are going to take a look at light in more details later and how we can use that for for composition and storytelling and all of those things. But for now, let's keep things pretty basic and take a look at what happens when objects are lit by one light source and what happens to the shadows as well. So let's start with how the different properties of color are affected by light. So we have a super basic setup here. As you can see, we have this big white light source in the shape of a sphere. And then we have this one object, which is also a sphere, being directly lit by that light source. And of course, we have the shadow right underneath here where the light can't reach. So in this case, in real life, this actually wouldn't be like this. So you would likely have some bounce light, even though underneath here is not directly lit by the light source. You would still have light bounces from that big light source, like bouncing off the ground here, bing, and then bong onto the sphere itself. So the bottom portion here would be slightly lit, even though it's not directly lit by the light source. Now, I can show you that by just increasing the quality here a little bit, and it'll make things a little bit more obvious what I mean. So if I enable kind of like the light bounces here, as you can see, I don't get that darkness so much. And I'm actually going to reduce the intensity of that light so that we can get a better idea. But as you can see here, so instead of going from light to complete black, instead it goes from a light to almost black, and then starts to be a little bit brighter again, because the light particles are bouncing off the ground and back onto the sphere. So light particles, they're particles, so they bounce around. And so this is kind of the setup that we are going to work with. So pretty basic. The first property that we'll take a look at is going to be the one that's probably the most obvious, and that will be the value. So the value here, as we can see, we have a really nice range, and that is going to be pretty much the case for most scenarios. So the side that is the closest to the light source, in this case, if you look at it from the side view here, so that one point here that is closest to the light source is going to be the brightest of them all. And then as you move away from that point onto, on the surface here of the sphere towards the other side, and then once it's past kind of like the midpoint, light is not going to be able to reach, and so the value will continuously drop and drop and drop until it reaches essentially zero brightness on the other side here, unless of course there are some light bounces. But right now I've disabled them, so that's a little bit easier to see the value change. So it's always going to be the same thing. The faces, everything that faces the light more directly and everything that is closest to the light is always going to be a little bit brighter. Now the next property that's often going to be impacted with light is going to be the hue itself. So as we can see here, if I bring up the actual color for the sphere, well, it's this right here. So it's kind of like this indigo color, but as you can see here on the side closest to the light source, it switches to kind of this magenta pink color. This is actually a phenomenon that's going to happen even if the light source itself is not particularly, cold or warm. And what I mean by that is, so if I bring this over here, which is going to be the color wheel again, all the colors that are on the left side, so I have kind of like the white line here splitting this in half, everything that's on the left, those are going to be considered warm colors. So the yellows, oranges, reds, all those colors are considered warm. And on the other side, so on the right side here, those colors are considered cool. And so this is going to, of course, impact kind of the how the colors shift. And what's really, really interesting here is that, regardless of the color that you have, whenever you have a light source that is neutral like this one, so this particular light source is not cool or warm, it's a, as neutral of a color as possible, it's just pure white. When it's like that, the majority of colors, the majority of hues will tend to shift slightly towards a warmer color. So that's not always the case, but usually that's what happens. And so, you can change any of the colors here, and this is going to be a little bit less apparent, the less saturated your colors are, but it's always going to go towards a slightly lighter or slightly warmer hue. So as you can see here, even the saturated starts in indigo and it goes towards more of a light pink color. And so the same happens with a lot of different colors. You can even see it with with orange, or with kind of like a dark orange here. So the orange, this one here, is the color that we can find in this area, but as it gets closer and closer to the light, it switches to more of a yellow color. So oftentimes, there will be some slight hue shift, so it's definitely not as drastic as the value change that we can see here, so going from really, really bright to really dark. But there often is going to be some slight change of hue in here. Now, of course, this is considering that the environment is as sterile as possible, so there's no colors anywhere else, right? As you can see, the ground is completely white. There's no color to that. There's no colors to the rest of the environment. There's no sky or nothing like that, and the light source itself is completely white. So in this case, even though there's nothing affecting the sphere, there's still a slight shift of hue. Now you can imagine that if the color here, if the sphere itself, had a red color, for example, or a blue color, or different kinds of colors, of course that is going to affect the color of the sphere in more noticeable ways. But in this case, we're going to keep things simple. We're going to keep the light source white and everything else white, so that we can have a better understanding of kind of just the basic effects that the light has onto the property. So then this brings us to the last of the properties, which is going to be a saturation. So saturation, well, we can see here, there's not going to be much of a change actually. So if I bring up kind of like the colors here, and we can pick the colors to see the change in saturation. So if I pick this color right there, right in the orange section here, you can see it's pretty saturated, right? If we look at the little circle here, you know, the white circle on this color scale. But what we can notice from this is really the saturation stays in the same spot pretty much the whole time, right? So it stays on the same line, on the same vertical line here towards the side, which was, well, basically kind of the original saturation for that color, right? So this is the saturation here. The square is not the square, but the circle is right there. And so it's not going to really move towards the left or the right. It's going to stay at a very similar saturation pretty much throughout, maybe a little bit less here towards the top where it switches to a lighter color, but still very, very subtle. Of course, when you get to pure black, well, that's something else. There's no saturation there. But yeah, as we can see here, the light is not going to affect saturation a whole lot. So other things might, but the light itself, not really. So the biggest change in the color properties is going to have to do with values like we've seen. So the value is definitely going to be impacted in a big way when it comes to light sources. And the hue might be affected a little bit and maybe more depending on the color of the environment or other elements in the scene. But the hue is still going to be affected, but really not so much. And then the saturation, on the other hand, not going to be affected at all, or at least not much at all. So a negligible amount that we can almost ignore. So that's going to be the main effect that the light has on the color properties. Now, if we take our attention away from the actual colors and start looking at the shadows now. So there's one thing that's really important to understand when it comes to shadows, and that is that there are two types of shadows. And you can also say there are two types of lights for that matter. So there's going to be soft shadows and hard shadows, or soft light and hard light. It works a little bit better when we talk about shadows. So essentially what a soft shadow is going to be, well, it's pretty much what we see right now, right? So it's going to be a soft transition between light and darkness. That can definitely change. And there's two things that are going to be impacting that shadow, essentially making it softer or harder. One of those is going to be the distance of the light source from the object that is being lit and the size of the light source. And so those two things can go hand in hand, you know, the sun being probably the best example. So it's a massive light source, but it's really far away. So, you know, the distance in this case is going to be the deciding factor in how the shadows from the sun are going to look like. If you've ever noticed outside, your own shadow actually is going to be really crisp, really hard. So there's not going to be any kind of fuzziness going around there. And that has to do with the massive distance between the light source and the object, you in this case. And we can also replicate that massive distance by making the light source smaller. So it used to be pretty fuzzy when the light source was big, but now the shadow is really crisp. Yeah, the bigger or the closer the light source is, essentially the bigger that it appears in comparison to the object being lit, the softer the shadow is going to appear. As you can see here, you know, it's a really big light source compared to a relatively smaller object. In this case, the shadow is going to be super diffuse, so very soft. And that has to do with the amount of light particles that can come in contact with the shape, or actually the amount of light particles that can reach behind the shape here. So as you can see here, I just kind of picked a few spots here. Of course, each of these spots, there's an infinity of them all over the surface, and each of these individual spots shoot out an infinity of light particles. But in this case, I just make sure to pick a few so that we can have kind of a good idea of what can reach and what can't reach behind. And so this really is what indicates the softness of the shadow. So in this case, if I take this light, this spot right here, so all of the light rays that this spot here is going to be able to shoot, let's say we limit it to this side here. So this is going to be kind of like the limit that we decide for the light. So there's no light particles that are going to go any further left than this. So we'll have one hit here, one hit here, and another one right there. And then if we do the same process with all of these points here, making sure that they land at the same spot. That's not real, but it's kind of like a really organized version of reality. And so what we can start to see here is that, since on the outside here, we're getting hit by a lot of different light particles, right? So we have the red, the orange, the cyan, and the purple particles hitting here, which is why, this is really, really bright. Well, not really bright, but it's like the brightest gray of the area. And then as we start to go towards the shape here, suddenly like fewer and fewer light rays are able to hit. So as you can see here, if I reach this area here where there's only 3 of those lines are able to hit, because the purple one here, it can't go past the shape, right? So all of the light particles that would be maybe lower than that, well, they would hit the sphere instead. So the only one that can actually reach the ground is the one that comes really, really, really close to the sphere but doesn't actually touch it. And then this one can reach all the way up here, but it can't in here. And so the other ones will be able to here. So 3 lines here, 3 lines here, 3 lines here, 3 lines here. But then what happens here again is that the cyan particles can actually reach. So of course the particles are not really cyan, but in this case, in this example they are. So the cyan line here can't reach past this point because otherwise it would just land right on the surface of that sphere. And so as you can see, as we get closer and closer towards the center of the shape here, fewer and fewer light rays or fewer and fewer light particles are able to reach. In this case, if we're all the way back here, there's only kind of like this one red light particle that can reach, and then beyond that, there's no more, right? So even if we had a point all the way down, all the way up here, it would still be pretty much the same thing, which is why after this point it's dark, and then it starts, the same thing again on the other side. So essentially, because this shape is so large, it's able to spray a lot of particles in a bunch of different directions. And in this case, since it's bigger than the actual shape, it's also able to shoot light particles kind of behind it. And the difference in the amount of light particles that are able to reach behind here versus on the outside here is gradual. As you can see here, it doesn't go from 4 to 1 directly. It's a gradual shift. So there's fewer and fewer as we go towards the center here of the shadow. And as a result, this gradual shift, well, that indicates also the the softness of the shadow essentially. But as there's less area for the light to wrap around the object, that shadow becomes sharper and sharper. But to really understand kind of the difference between the distance and the size, in this case, we're going to reduce the size and not the distance. So the distance of the light source is still going to be as close as it used to be. But as you can see here, the light source is significantly reduced. So it's smaller, or maybe not smaller, but it's the same size or smaller than the object itself. So there's not going to be any kind of light particles that can reach behind the object like they could before. But still, in this case, since the light source is fairly close, we'll still get some sort of softness to the shadow, even though it might not be as much as before. So it's not going to be perfectly sharp. And the main reason here, again, the same logic, right? So we have 4 light particles here that can hit in this area, 4, 4, 4, 4, 4. And now it changes to 3 because the purple particles can't reach anymore, because otherwise, they would just hit the sphere instead. And so we dropped to 3 all of a sudden. It's been 4 all along, and then 3, and then 2 right away, because now the cyan, past this point can't reach. And then after that, there's nothing, right? So after that, it's just pure darkness. It's just the shadow. But as you can see here, between the shadow and between the light area here, where there's as much light as possible, there's still going to be some slight softness here. So the switch is definitely more sudden, and the softness or the fuzziness around the shadow is going to be much tighter than before, but there is still going to be some softness to the shadow. So now if we take the same light source, not touch the size of it, but actually increase the distance and bring it really, really, really far away from that object, and we can actually increase the intensity a little bit. Now if we look at the shadow, which is going to be pretty hard to see now that the light is so far away, but as you can see here, it's a lot crisper than it was. It's a lot harder than it used to be. And bring it closer. Now we can see the difference really clearly. It's super soft. So then, to more clearly illustrate kind of the impact of distance, because that is going to be something that's pretty different compared to what we've seen so far? Well, I've recreated kind of a situation where we have something similar to the Earth and the Sun. So of course, it's not going to be the same thing because the distance is nothing in comparison to what it really is in real life. But if I take my light source here and move it really, really, really far away from the subject, maybe something all the way up here. And what we can do now is we can take the same light rays and just deform them. So bring them up again so that they originate from the light source as they should. So it would be something like this. So now what we can see here, so it's not perfect, right? But really what you should be looking at now is how parallel all those lines are. So I'm not infinitely far from the subject, so I'm still pretty far, but it's nothing compared to, let's say, the Earth and the Sun, right? So the actual Sun is way, 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 way further away than that. And so if all those light rays were actually originating from the Sun, instead of being slightly, almost parallel like they are right now, they would all appear to be parallel instead. And so as a result, well, the light rays, for example, like these here, like the purple ones that normally wouldn't be able to hit, any further than this in the previous example. Well, now if we trace a line, I'm going to try to do that. So if I trace a line going from here all the way down, now you can see that it actually is able to hit really, really, really close here. And then anything behind that sphere is now going to be visible. And then we can do the same test with the cyan line here. Make it start all the way to the top here and go down, 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 and see if it can reach. And it can indeed. So before, it used to stop around this area. Now it can go all the way to the side of the sphere here. So with this, well, what can we see? We can see that before the light intensity was maximum starting from here and outwards to the left, right? So we had the 4 light rays here that we're able to hit, and then past that line, so past this one line, there was only 3 until there were only 2, and then 1, and then none. But in this case, as we can see here, if the 4th and the 3rd, so the cyan and the purple, can hit all the way here, of course, it means that they can hit here, 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 here as well, right? There's no reason for that not to be the case. And what this means is that we have full brightness all the way up here. And then once the shadow starts, 0 brightness at all. And so there's not going to be any kind of gradient in this case. It's going to be from 100% brightness to 0% brightness. And this is the only way that you can achieve this, perfectly crisp shadow. And that is something that is, again, unique to light sources that are really, really, really far away. So far away that their light particles, or the light particles that they emit, appear to be parallel to one another, as you can see here. So before it wasn't like that, right? So before those lines used to cross each other. In this case, they don't. They're just parallel to one another. So as you probably can guess, this is a type of shadow that is going to be pretty much unique to the sun for that reason, because the sun is the only light source that is so far away from us that the light particles that reach us appear to be, parallel to one another. So when it comes to the 2 types of shadows, this is going to be pretty much it. So again, the light, the distance of the light, and the size of the light source. Those are going to be the 2 main factors when it comes to the type of shadows that you'll get. And moving on then from that, there is something that's really, really important. And this is what we are going to end this chapter with. So now that we know all the logic and kind of theory behind it, now it's time to actually try drawing our own shadows. So we're going to start again very, very simply with something that's super basic. Again, a sphere. So I'm in a different software now. So I have a sphere right here. I am going to light it up, bring in a spotlight here. So, don't pay attention to the environment or anything like that. What we're trying to look at is really the shadow that we get from this spotlight. So really the main exercise, right? Or the main goal with this is to be able to, without having a 3D scene like this to be able to help us, by just drawing kind of like this sphere right there on a sheet of paper or in Photoshop or whatever, and having a placed light source in your environment, and that can be anything, right? You're the boss, you do whatever you want. And once you have those two elements, now comes the time to figure out what the shadow is going to look like. So this is something that is incredibly hard. It's really, really hard kind of brain exercise to do. Really, it's definitely one of those harder harder skills to develop as an artist, figuring out what the shadow is going to look like. All right, so now that I'm done scaring you, I want to mention that there are some things that we can do to get or at least to help us get started when drawing shadows, and I'll show you all of that a little bit later. But for now, I want to give you kind of a quick trick, a quick tip on how to train or start training your brain to see things different, to see light differently, and this is going to really help eventually, figure out how the shadow is supposed to look. The one trick that I found that really, really helped me over the years is to try and imagine that I myself am the light and I'm looking at this scene. So instead of looking from this point of view, I'm instead looking at the scene from the point of view of the light. Always try to imagine you are the light looking at the environment, and try to picture in your brain what you see. And what you see is going to be, where the light is going to be applied, and what you don't see from that particular angle, this is where the shadow are going to be, because there's not any light that are going to be able to shine there. And so that's it, right? That's the end of the trick. It's not really a trick, like I said, it's more of an exercise, but it's something that you should definitely try to do as much as you possibly can. Try to imagine you are the light in the environment, and try to imagine what you see. What you don't see is going to be in the shadows. If I take this other example, slightly more difficult. So in this case, I have two different spheres, and then one is kind of overlapping the other one, right? So it's casting shadow on the smaller one. So now, from the side view here, it's really hard to imagine, if you didn't have those shadows already, it makes things really, really hard to figure out where is this going to land on my floor, on the ground, right? But now, if you try to imagine that you're the light looking at this whole scene, then you can try to shift your point of view, try to shift your perspective, and now you're imagining that, okay, I have this really, really big sphere in the center, and then I have this smaller sphere that's on the side here. So this one is going to be pretty much halfway covered by the shadow of this one here, because again, remember, what I don't see is in the shades, since I am the light. And so I know that this smaller sphere, pretty much the half of it is going to be covered in shadows, and as a result, on the ground I'll have a big circle or a big ellipse, and I'll have a smaller ellipse, and that smaller ellipse is going to start not quite in the center of the bigger ellipse, but maybe a little bit further back. And so if we look at the actual shadows now, what we can see here, if we look at it from the side view, that's actually quite correct, right? We have this big ellipse, we have this other smaller ellipse that doesn't start quite at the halfway point, but a little bit past that, right? So it's not quite centered. And also, well, we can see that the two ellipses are connected, and this one here is kind of overlapping the smaller ellipse. It's difficult. Granted, this is not an easy brain exercise. This is super, super advanced stuff, but it's something that you should try and practice every chance you get, because it's only going to improve your result. And when you're able to draw shadows really, really well in your drawings, in your paintings, in your environment, whatever it is, this really impacts your art in a significant way. So it's one of the things that, even if everything else is kind of bad, or not bad, but like so in your drawing, if you're able to create realistic, believable shadows, it changes absolutely everything. So this might be a little bit subjective. At least this is definitely my preference, when it comes to the full result. Lighting, to me, plays such a big part. It has such a high level of difficulty to execute properly, that whenever it is executed properly in the painting, it really brings everything up with it a lot, like significantly more than pretty much everything else could. And so again, this is just kind of my point of view, but just looking over the years at what people respond to the most when it comes to art, and it's always going to be those paintings or those drawings that have really amazing lights and shadows. And so this is going to be the end of this chapter on light, and then in the next chapter we'll take a look at how to actually apply what we've learned so far, so that we can actually start practicing this stuff. Because again, as usual, practice makes perfect. So I'll see you in a little bit. All right, in this chapter, we are going to be focusing on cast shadows. So far we've seen the two types of shadows, hard and soft. We've also seen kind of how light interacts with a simple volume in space, and that, in the case of the previous chapter, a sphere. And so now it's time to actually get in there and learn how to construct a proper shadow, because there are actually ways to properly construct it so that it's accurate. In this case, since this is the first class on color and light theory, we are going to be keeping it pretty simple. So we'll start with those 3 different boxes, and then those boxes might look the same apart from the color, but in reality this one is floating, so it's hovering above the ground. This one here is going to be the basic one, so this one we'll start with is just a kind of a box laying on the ground. And this one, well, the lights are going to be in front of that box, and so we'll probably cast a shadow on the wall as well as on the floor. So we'll have kind of a good overview with this of the majority of situations that you'll probably have to experiment with. And once we're done with these 3, we'll actually take a look at some more advanced shapes, still basic shapes, but more complicated than these. But before we get there, let's actually get started on these. So really quickly, what I have in here, I have 3 different boxes that are in 2-point perspective here, as you can see. So this is probably familiar if you've if you've seen the perspective class. This is what we'll start with. So what I recommend at the very beginning is to do exactly that. You can use any amount of vanishing points. We don't have to use 2-point perspective, any kind of perspective really, but just make sure that it follows some sort of perspective, and this is going to be a big help, as you will shortly see. And then the one thing that's kind of hovering there, this is going to be the light. And why is there kind of a string attached to it? This little thing here is going to be grounding the light in space, really. So this is also going to be something that's important, that little point here, where the light connects with the ground, because otherwise, if I don't have any ground for that light, well, the light really could be anywhere in space and I wouldn't be able to know. So if I only have kind of like this circle here where, well, is the light in the back there, or is it kind of in the front here, or is it on the side of that box? So there's really no way to know unless it's grounded. And so this is what this is really. So we're going to start, and it's actually going to be pretty simple, pretty straightforward. So there's going to be 2 different steps when creating the shadows on the ground. And well, for boxes like this, the resulting shadows usually going to have 5 sides, and those sides are going to be different for depending on which side the light is on. But in this case, in the first case, we'll have the shadow for this edge, that edge, that edge, that one on the other side of the box, and this one here. So 1, 2, 3, 4, 5, and these in red are going to be the ones, the kind of like the outside of the box that create the shadow. So this one here, that is closer to us, so that one edge right there and that other one right here, well, those are going to be in the shadows anyways, and you'll see that there's really no point to them because they're not going to cast any kind of shadows. They are already going to be in the shadows. And then of course the one on the ground as well, they don't cast anything, they're already on the ground. So I'm going to start then with the first step, and then the first step is the simplest of them all. It's always going to be 2 different lines, super simple, and we'll start with the ground here, the ground for that light. And all we'll have to do is trace a straight line starting from it to the 2 corners of that of the object. So in this case, it's going to be the 2 corners of that box here, but if it was like a cylinder, it would be kind of like the 2 outside extremities of that cylinder. And so all I'm going to do here is touch the corner and then continue the line. Do the same thing on the other side with that corner here that I can kind of see in transparency, and then continue the line as well here. We are going to move on to the light now. And so this is going to be the light here, and we can imagine that this is like the sun. So to keep things simple, we're just going to start our lines starting at the very center here. And what I'm going to do is trace a line connecting or touching all 4 corners of the top side of the box. So one right here, continue the line, another one right here, another one here, and finally this one here in the back that I can't quite see. So now I have a pretty good start. So what I need to figure out now is how to close this shape, right? So I have just a bunch of lines now. All my construction lines are pretty much done. There's only 2 more that I need to find out. And so what I can start to do then is work with what I have so far. So this corner here for that box, well, that corner is going to be this corner right there. So it's a straight line going from that corner to that point here, that intersection. So this point is going to represent that point. Now this corner here, well, I don't have anywhere, right? It just keeps on going. And so I'll need to figure out where is that intersection going to be here? So where is that going to stop? Where is that corner going to be on that line? So the way to do this, well, I'm going to use the vanishing points that I already used to create this box here, so we can kind of see them still. So the vanishing point is going to be right there. As you can see here, it matches all the sides for that side of the box. And so if I'm trying to find this side here, trying to find where this line is on here, well, what I'm going to use then is the same vanishing point, make sure that it connects here, right? So this is it. And then all I'll have to do is slide it down until it interconnects with the other red dot here. So just like it did here, make sure that it connects with the other intersection here in red. And now I will have my, if I continue that line, it's going to land right about there, right? I should have probably done it a little bit longer. But anyway, so this would be that side here of the shadow. So that's one. And I have the other 2 here, the other 2 side for that other edge of the box. So now I have the other ones to figure out. So the other ones are actually using the exact same vanishing point as this one here. So as you can see here, if I'm looking to find out where this line is, well, it's the same vanishing point again. So all I'll have to do is again, slide it down, slide it down, slide it down until it connects with the first corner like I did with this one here. So the first corner in this case is behind the box, but it's this one here, right? When it connects to that line, that intersection here. So what I'll do, same thing again, start from here, slide it down until it interconnects with that green dot. And then this is going to give me the other side that I needed. Then I have one side here, 2 side here for my shadow. This one we're not going to be able to see because it's behind the box, of course. But now I should have pretty much everything I need to complete this shape. So I have this point here. Now this corner here connects with the new line that we generated from the green corner here. So I'm not going to use the other one here, the one on the outside. That one's useless. It was only to find out the first corner. So I have this dot here, and I have this one here that is also there. And so yeah, now I'm just ready to complete the shape, kind of close this all off, and I will have my final shadow. From here to here to here, and then I can kind of go around the box. And there we go. And this is how you build shadows, really. So as you can see here, it's not that complicated. There's a couple extra lines to draw, but really, if you're able to create those boxes in the first place, creating the shadows for it should be really, really straightforward at this point. So of course, this was an easy example. So now we're going to move on to a slightly more complicated one. Not that it's going to be that much harder, but surface here is going to change. So instead of having 5 sides to our shadows, we'll probably have some more because there's going to be a break in the line. And so we're going to start exactly the same way then, with the 2 lines starting here at the root of that light. So touching the 2 corners here on the outside, projecting that until it reaches the wall, because it's going to change direction after that. Now I'm not touching these other corners because then the line would have to go through the box, and that is no good. That's not how this works. Now I'm going to move on to the actual light itself up here. So do the same thing here, connect with the 4 corners of the top portion of the box, right? So the lines or the edges that are going to be projecting the shadows are going to be this one right here, that one right here, that one in the back, that one on the side, and this one right there. So 1, 2, 3, 4, 5. So those are going to be the 5 edges that cast the shadow. Now let's start with the corners at the top here. So I'm going to just extend them as much as I can here, going through all the different corners of that box, even the one behind here,
and the one on that side here. So it's good to start from the same point. You know, my lines are not perfect, but it's good enough. So now what I have these 2 points here. So this one's going to be correct, and that one here where it connects there, that one's going to be correct as well. So these are those corners, right? Now, I am going to need to figure out the line going from here to here, what that looks like on there. And so to find that, again, I'll need to find the original vanishing point that created those edges. So it's going to be this one here. We can kind of see it through the wall. It's that one right here. And then I'm going to slide it down until it connects, until it intersects with that dot, that blue dot here that I just drew. And so we'll have now this side of the shadow done and that side of the shadow done as well. But now when it touches the wall, it's of course going to change directions. And then so normally what I would do to find out kind of like the rest of the line is just continue that line here until I reach the intersection there, right? But in this case, since the wall is changing angle, well, all I have to do is change the angle along with it and go straight up, because the wall is in this direction, until I touch the line then. And so this is going to be this dot right here instead. You know, it's not going to be this one there. It's going to be a little bit higher in this case. So there's going to be that same corner right here. And now, well, I just have to do the exact same thing on the other side here. So I need to find out this line here, where it lands on the ground. So I'm going to start with the same vanishing point here, the one that created that edge, and slide it down until I touch the blue dot. And now I know that my shadow here on this side is going to go like this. Then now to figure out the missing line, which is going to be this line right here, right? I'm trying to find where is this going to go. And to find this, well, it's going to be that same line right here. So it's this edge of the box that I'm trying to place, because I already have this corner here, right? It's the yellow, the orange corner that I already have. And now I'm trying to find the other side. And so if I follow the line, it's going to give me this corner right there. And so now what I can do, like I did here, is try to find the vanishing point for that line, so for that edge of the box. And in this case, it happens to be the vanishing point that's a little bit further away. That's about right there. So right about there. And so what I can do now is, starting from here, touch or make sure that I'm right onto the right edge here. So that's good. And then slide it down until I touch the other side here, the other orange side. And then I can stop there. And this is going to give me kind of the top portion of my shadow on the wall, like this. And so we continue here, all the way here, and then from here it can just go up until it touches that new line, and then close the shape. And that will be the shadow that I have for this particular example. So of course, all the stuff in the back we're not going to be able to see, so I can kind of ignore it and just fill this in instead. And there we go. And now I'm left with again a nice shadow that interacts with two different surfaces, so the ground and the wall. So again, not too hard, right? It's the same process. It doesn't matter how many surfaces there are, as long as we follow the same rules, the same process, things should work out. Now, moving on to the last example here. This one's going to be a little bit different, a little bit more complicated in the sense, because this one is actually floating off the ground, so it's not touching the ground. So the first thing when you have a floating object, it will have to be to ground it. So in this case, what would happen if this box were to drop straight down to the floor? Well, I just traced kind of like an arbitrary floor right here. It could have been a little bit lower, doesn't really matter. But in this case, you know, this right here, those are going to be my corners for that box if that box were to drop. So if it wasn't floating. So I know that it's floating by about, you know, this much. So the reason why we need this is because to trace the initial two lines for the ground here, starting from the ground of the lights, we need those points to be grounded because it's the ground portion of the shadow. And so this has to be on the same level. It has to be on the ground level. So it wouldn't be able to jump up in the air to touch that corner. And so for this particular example, instead of having instead of having 5 sides like in the first example we saw, this one's going to have an extra one because it's floating. So I'll have this side here, that side there. I'll have this side here on the side, that side here on the other side, the back side, and then I'll have one more. So this was kind of the setup that we had for the other boxes. But in this case, since this one is floating, I'll actually be able to highlight this one as well because this edge is going to cast a shadow. Before it didn't because it was already resting on the ground, but in this case it's floating, so things are a little bit different. So then other than that, it's exactly the same process. So I'm going to start here from the bottom, extend those lines touching the fake corners, so the corners that that box would have if it were touching the ground. From there, I'm going to trace all the other lines, starting here from the light to all these corners for the top of the box. So that corner here, that corner there, and extend those, plenty. That corner there in the back, that corner there on the side, and of course the 2 corners at the bottom here of the box in the front. So if you're unsure, of which corner you should select, well, you can just trace it for every single corner, and then you'll see, as you work on it, that there are some of those lines that are not going to be used, and so, over time you'll just kind of learn which ones to ignore. So now I'm going to color code my corners again because that helps quite a bit. So the first corners here that we already have, they land right on that line here. So I have my first 2 corners for the shadows. So I know that the first edge of the shadow is going to be this one right there. Now I need to figure out this one here. So this is the next one in line. To find this one out, well, it's going to be that line here that touches that one corner. So it's going to be that one line that I need to find. So this line continues, and touches here. So this is going to be the first corner. Next up is going to be this side here. So far I've had this corner here. I've done this one, that one. Now I need to figure out this line in there. So from here to here. So I know that this one is going to be kind of like the blue corner. And I need to go to the red corner. So where is the red corner going to be? Anywhere here? Well, again, like we've done so far, I need to figure out that line here, what vanishing point made it, and it's going to be this vanishing point right here. So I have the vanishing point there. So all I have to do then is trace the line, make sure that indeed it connects, and then slide it down until it connects with the blue dot. And then if I follow the line here, touching the red dot, it should give me the other location for the other red dot here. And then I'll have the other side of the shadow done. So I already have kind of 3 sides out of 6, so only 3 more to go. And yeah, we're going to do the same process on the other side here. So now I have this corner there and that line here. So now I need to find out what where that other line is going to land. So this line right here. So where is that going to go? So where is that dot here? And in this case, well, I just need to follow this here, and it's going to be right about there. So what I can do, trace it here and maybe a little bit lighter until it touches it here. So now 2 more edges to go then. To find out the last ones, well, it's going to be this edge here. So the other side of the box that we can't see. And I need to find out what vanishing point I used for that again. And it'll be the same here as this one. So then I can start from here and then slide it down until it touches the yellow dot for that one corner. And our mission was to find out the other side, so the purple dot, right? So I have the yellow dot already right here. Now, if I continue that line here and I continue that line here until these 2 merge, then I'll have kind of the other corner here, the other purple corner. So now I have my 2 orange corners, my 2 purple corners, and I can trace kind of the last line here for the shadow. And then pretty straightforward. All I can do from now is just close the shape like that, and I have my shadow for this floating box. Now I'm going to clean this up. There you go. So now I can just erase, the other side here that I'm not going to be able to see, and I would be done. So as you can see, constructing shadows is not that complicated when the shapes that we're working with are pretty simple. In this case, simple cubes, pretty straightforward. Yeah, at this point, we should be able to do this, create accurate shadows for different types of light sources, different types of scenarios. Now, the last thing I want to do here really quickly is to add a little bit of shadows onto those boxes themselves. What I'm going to do now is figure out the side that is facing the light. So in this case, if I know that the light here, when it touches the ground, is down here, the shortest distance to the box would lead me to this side here, which would be, this side of the box there. It wouldn't be this one here, because for that to reach there, I would have to kind of go around, and that would be a longer path. So the face of that box facing the light is going to be this one here. So this, on the other hand, is going to be the one that needs to have a little bit more shadow. So what I'm going to do, I'm not going to change the saturation. So I'm not going to go left or right. All I'll do is color pick the color that I already have and slide it down to reduce the brightness. That corner is in the shadows, in the shadow properly. Now I'm going to do the same thing here. So in this case, the light is on the other side. So those two sides are going to be in the shades. As you can see here, they are already connected to the shades. So it's going to be pretty straightforward. All I can do is select, color pick the same color, slide it down to modify the value, reduce the brightness, and then I'm ready to add those colors in. And maybe to make it look a little bit better, I'll have one side here, the one that's completely opposite to the light. This one here is not as it's not facing away as much as this side here. So maybe I'll make that one a little bit darker. All right. And then finally, this one right there. Well, the same deal here. I know that I have my ground there, and the closest distance, the first face that I touch, if I trace this, a direct line to the shape, is going to be this face right there. So this one's not going to be in the shades at all, but that one on the side, the one touching the shadows, is. Same process again. And there we go. So now not only do I have proper cast shadows for these, but yeah, they're also shaded properly as they should with this light source. Okay, so now let's try something a little bit more difficult, and we'll use a not as many construction lines, so it'll be a little bit more like winging it, but we'll use kind of the same idea and the same process. Just we'll skip a couple things here so that it's not as tedious. But yeah, we have 3 different shapes in here, so as you can see, those shapes are a little bit more complex to create shadows for, especially since this sphere here is floating and I have kind of like this weird gate looking thing. And so what I have now, well, it's the same as before. I have my lights, I have the ground for my light, so I kind of know where it's situated in space. In this case, it lands in front of all of these things. And so I also have a ground for my my sphere, and the other objects are already grounded, so no need to do anything there. Then let's just get started with the sphere. And so it's going to be somewhat similar to what we've done so far with the boxes. So the first thing we need to figure out here is going to be kind of like just a basic perspective for this scene. So I have a vanishing point here that I used to create this cylinder. And so I'm going to use that one, have it go through it right here. And I'll use another one based on the cylinder as well. So maybe something like this here. So I can use again that one here to go through the center. And there we go. Starting here, there's a couple things that we'll need to do before we're able to actually start working on the shadow. So we'll have to figure out kind of the measurement or some sort of measurements for the sphere here. So in the case, if you were building that sphere out of a cube, for example, we would have had all our measurements already done and everything would have been based on that cube, so it would have been a lot easier. But if you start with a sphere like this, which is, probably something that's a little bit more convenient, well, there's a couple things that we'll have to do. So first things first is going to be finding what that shadow looks like, if it were lit from the top here. So we need to recreate that sphere here underneath like this. And so we'll have kind of like a way to measure the difference between the two in the proper perspective. So to do that, well, I'm going to start here from my vanishing point, and what I'll do is just continue the line until it touches here the bottom or the center anchor for that sphere. And then I'll do the exact same thing for this other one right there. That I'm left with something like this. And then I am going to trace these sides here and make them go all the way down. So then if I start here at the center of the triangle and then go through the middle here onto the other side, this distance is going to be the diameter of my sphere seen from the front without any kind of perspective distortion. What we're going to do then is, starting from the vanishing point, I'm going to connect to these intersections here. So one there another one there and kind of keep going, and on the other side as well, so touching the corner here. So what I'm left with then is going to be this shape right here. And the reason why I wanted this square here is that from here it's really easy to figure out the actual curve that should be here, right? So all we have to do is use the points that we have, the corners for this box here, not this box but this square, and then just kind of round them out. And so I'll be able to get kind of like the shadow that this sphere would cast if the sun was shining straight down. So now with this, what I can do is actually a lot of different things. So now that I have kind of like this ellipse back in here, well, I'll be able to find out a lot of things now. And the first line that we are going to draw after this is going to be the one starting here from the root of the light, and we'll go all the way through the center of this this shape here, the fake shadow. And then like I've seen, in the previous examples with the boxes, I know that if I trace a line starting from the same spot here and touching the edges here of that ellipse on both sides, I know that my result, the resulting shadow, like the real one, is going to be somewhere in this area right here. All right, so with this now, what this line gives me, the line, especially the one in the center, going through the center of this shape, what this gives me is going to be the point here. If I change the color, so the point on that circle. So now if I extend this thing upwards like this, right here in this perspective would be the kind of like the front or one of the poles for my shape. And I can do the same thing here in the back, kind of extend the back side, and I would land right about there. And so what I can do with this now is I have everything that I need to be able to split this sphere. So I can create a nice oval like this. And now I know that if I trace a line starting from here all the way to the center of the circle or the center of the sphere, the intersection that I get, so this one right here, this is actually going to be the brightest spot on my sphere. Not only do I get a nice little indication here of the brightest light spot on my sphere, but it's also going to give me kind of like the starting point for the next ellipse that I'll be working on. And so right now this ellipse is not super useful. Otherwise, the one that I want to find is going to be the one that looks like this, the one that's facing this light spot, because that is the ellipse that will be projecting onto the ground. If we're not using that ellipse, things are not going to look quite right. And so this is going to be the indication here. So I have 2 dots now for this particular ellipse. Now what I'm trying to figure out is how can I make it perpendicular to this line here? Well, pretty easy. All I'm going to do is start with a perpendicular line to that red line. So something like this, and then I'll have my 2 new poles. And then what I can do from here is just create a nice ellipse like this. All right, so it's not going to win any prizes, but it does the trick. And so really, all I need is to project the actual shadow, because I have all the stuff that I need. So let me explain why. And so I have one point right here. I have this point here, the cross section from this convergent line. I have this other point right here. So those are going to be my 2 initial points I'll be projecting on there. And then the other ones that I'm interested in is going to be this one here in front where the 2 meet. So this is going to be kind of like the cross section perpendicular to this one, and also the cross section facing this light. So this point right there, and of course that one up here. So those are going to be the points that I'm projecting onto these lines here. Now, if I project those lines using the light source now from here and go through all those different dots. So in this case here, the 1, 2 in the middle are going to go onto that middle line. So I'll have this one here land right back there. That one here lands here. And then we have the 2 on the sides here that are going to, land on the sides that I already have there. So one here. And finally, this one here on the other line. And now I have 1, 2, 3, 4 points that I'm able to connect to give me a new ellipse that is going to give me my actual shadows. There's one more thing that I want to do, and that is going to be the outside. So I'm just going to have one more line so that I know that this is going to be the limit for my shadow. It's not going to go past that, and it has to actually match that line, right? So even though I have my 4 points here, the shadow will have to go and touch here for it to actually work. Now, just to make building the circle a little bit easier, I'm going to add one more here, going from this point to that point. So in theory, these 2 points should be pretty much lined up. So I made some slight mistakes, but you know, they're pretty much there. And so anyways, I can go and jump into the ellipse right away. So, and yeah, so there you go. So it's not perfect, but it's not bad. And so I can fill this in, and my shadow, my cast shadow for the sphere would be complete. So yes, it's a little bit more complicated than the initial boxes that we saw, but as you can see here, we can still definitely reconstruct this without too much issues. So now I'm going to hide all of this, because now we're going to actually shade this sphere. So we have everything we need already, so we don't need to do much more to it. So I'm just going to make a selection here so that's a little bit easier to paint. But essentially, like I said, this point right here is going to be, you know, this pole right there. This is going to be the brightest spot because it's the closest to the light source. And the opposite here on the other side of the ball, where this is going to be the darkest, considering there's no bounce light, because it's going to be the complete opposite. So it's going to be on the other side here, on the dark side. And then what this purple ring really means, everything that is below this line on that side is not going to be receiving any kind of light because it's past the halfway point. Everything else is going to be brighter. And so I can fill this in. And of course, you know, the separation here between light and shadow is not going to be as defined, so I can soften that out. And what I want to make sure is that this point here, this is the brightest point on the entire sphere. So not only did we get a shadow out of this, but we also got the information that we needed to actually shade our sphere. So yeah, there we go. So looks pretty good. As you've seen, you know, we have a nice shadow now, and with the same information that we kind of collected by building this shadow, we've been able to actually come up with the shading, the accurate shading for that particular sphere in this particular perspective with this particular light. And so this is how it's done for a sphere. Then let's move on to the cylinder. And as you will see, it is a lot simpler. And so it's only going to be a few steps. And what we are going to start with in here is going to be the line here starting from the light. So from the root of the light, touching each side of that cylinder. This side and that side here. As you can see, or maybe not, but you know, there's kind of like the transparency here. So really what I'm doing there is trying to hug that outside curve. And then I'll have one more that goes down the center for the cylinder. Now, once we have that, we need to split the cylinder along the other axis. So like this, so that we have nice, 4 nice equal parts, or at least, you know, if they were laying flat, but right now, you know, they're pretty much equal. And what I'll want to do also is do the same thing here and kind of slide these up along the side of the cylinder. So in the front here, it's not going to be really relevant, but the one in the back here, this one here, where it intersects with that edge. So I want that point, and I want the other 2 points for the outside. So this one here, right there, and the other one right here. And so those are going to be the points that I use to finish off the shadows. As you can see, it's pretty simple and pretty quick. So all I have to do now is have them go through here. This one's going to land on the center line, this one here on the outside line, and that one on the other one here, which we probably won't be able to see. And now I should have my 3 points, 1 point here, 1 point here, 1 point here. And I know that this line here is also kind of like this, if this was a circle, that would be kind of like the halfway point. I just need to recreate kind of like that, you know, that same curve right there. So I can actually look at this here to do something similar. Fill this in. And there we go. So now we'll do the shading for the cylinder, and I can actually, you know, keep this point right here. So the points that I didn't really use before, the purple one now, that is going to be blue now. This is the one point that is closer to this light source here. So if I trace a straight line, the first point that receives the light is going to be this corner. And so this edge, you know, this corner here especially, and then along the edge, this is going to receive the most light, the most direct amount of light. And so I can also know that along this magenta line, this is also going to be the one side of the cylinder that receives the most light, because it's the one facing the light source most directly. And what this means then is that we can use that information to create the shading for the cylinder. So I'm going to start with a mid-gray color. Careful not to paint over too much so that I can still have my guidelines there. Go towards the top, maybe it'll be a little bit lighter because the sun hitting it a little bit more directly than the sides. But the one point that received the most light is going to be this point right here, like as we've seen, and this side of the box. And so it's going to be pretty even between the top and the side of the box here. I would tend to guess that the top will receive a little bit more light because it's facing the light a little bit more directly, but we can still use our guidelines here for the side of the cylinder to indicate or to properly paint kind of like the gradient of color going from light to dark. There we go. So it's as simple as that. This example was particularly easy. And now moving on to the last example. Like everything else, we need to turn this into a simpler shape. So right now it's kind of like this gate looking thing with a hole in the center. And we are going to have a really hard time if we're just trying to, from imagination, project that on here. So what we'll need to do is turn that into a box instead, and then project a box. And then after the box is projected, then we'll be able to add in the curves that are needed here for the top portion, and add in kind of the curve for the inside as well. For this one, I'm going to add a little bit more guidelines here. So I'm going to consider that this is a box here. And you can see the line is not even straight. So, and the vanishing point for that gate started back here. So this is going to be the vanishing point 1. This one is vanishing point 2. Back side of the box, back side here. It's going to extend this upwards like this, up until it touches. Do the same thing on the other side. Now that should be a little bit easier to work with. And there's one more line that I'm going to add, and it's going to be the one for kind of like the opening here. So where it switches, where it transitions from a vertical line to a curve here. So that's about right there. So I'm going to have another convergent lines for that one point. And so I know that my box will be split kind of like that. All right, so this should make things a little bit easier now. So all I have to do is, well, the same that I've done so far. So I'll figure out the line for the base here, starting from the root of my light. And so that's what I'm going to do next. So starting from here, I'll have a line that touches that corner right there. And so we can consider like the two legs here as two separate boxes, right? So we'll have, instead of 2 lines, we'll have 4 lines in this case. So if I trace kind of like the transparency, on the other side, it would be that corner right there, a corner here, and a corner here in the back. And so that's going to be the line that I use for this. Touch that corner here and keep on going. Same thing here. So touch this corner here and keep on going. And in this case, this is going to be the outmost corner that I am going to touch here. And so it's not going to be this one in front, and it's not going to be that one in front here. So I should probably make that line go a little bit further. So now, well, what I know is that the shadow is going to start like this, and it's going to extend in that direction. Now, what I need to figure out is how far and what that curve here at the top is going to look like. So then the next step is going to be to move on to the light source here, and we'll be able to trace and figure out kind of like where these corners here at the top of the box land on here. So similar to what we've done with the first examples that we did, with the different boxes here, I'm going to go ahead and touch each of these corners that I would normally see. So this one, that one, that one, and that one. And so this corner here, if I switch to a color instead, so it's going to be a little bit easier. So I'm trying to figure out where that corner is, where that corner is, where that one is, and where that one is on these lines here. I'm just going to project, try to figure out this one here, so the beige one. So I know that this point is going to be right here. I'm following the same line here. Then I can do the same exercise for the green one. Touch the green and touch the inside. So the green is going to land right here. Same thing with the purple or the violet. That's going to land right about there. Then if we project the blue one here, well, it's not going to really be useful at all because this one's not actually going to impact the shadow whatsoever. So we can kind of ignore that one. And then what would be left really with the outside for that box here. So I can trace this one here. So those 2 points would be those two right here. And I have this right there going from here to here. And then finally from there to, well, this side here, right? So this, I already have that drawn. So that would be kind of like the outside of my box if it were projected. And then, well, the last thing that I need to figure out then is where this line here, or where this separation here is on the ground. And so, well, to do that, I'll try to split my box in half. So I take kind of like the halfway point here, split that down the center, which will land right about here. And so I can extend the line here through the center and then up here until it touches, starting from here, touching that point and where it lands exactly on that line here until it connects with it. And that would be right about there. So now if I have the proper perspective here, so I know then that this line is going to be the same as that line right here. So really these points here on the side is going to be the ones where the circle or the curve is going to begin. And now from there, what I'm going to do is split that in half like this. So I know that this portion here, the top right there, this is going to be the top, the equivalent, it's going to be this point right there. And so I know that this is the top of my curve here. So really what I can do, since I also know that this corner here is going to be that corner there. So I have a point here, and I just need to connect the dots now. So I know that the curve is going to go from something like this, touch here, and then back here. And the curve on the inside is going to be very similar. And so if I try to figure out kind of where that top portion is, I can use the light again, touch until it touches here. So I know that right there is going to be the top for the arc. And yeah, then things are pretty simple. All I have to do is create the shadow for that, or recreate the curve. There we go. So really roughly, that would be kind of it. Now what I can do is clean this up on the separate layer. Now hide all my guidelines, and I should be left with the shape for that shadow. So there we go. So that's it. It's not too complicated, not that many construction lines. I mean, there's a decent amount, but this example is very, very similar to the boxes that we've done in the first part of this chapter here. So I can also erase this bit here. And so, yeah, it's just a more complex box. So there's just a couple more steps after we find out kind of like the basic stuff that we did for the 3 box examples that we did at the beginning. But other than that, still the same process. And now what I can do is try to figure out how the shading on that thing would look like. So again, similar to what we've done so far, need to find out the halfway point here, a direct line then from the light to this shape. If the center of that shape, if the top of that curve is right there. So this point here in red, that is going to be the point that is closest to the light source. And like we know, this means that it's going to be the brightest. Everything else is going to be darker than that. And of course, I have the sides here of the box that are connecting with the shadows, with the shade in the bottom here at the bottom. So I know that this side is going to be in the shadows. I know that side on the inside as well. So I can kind of start with these. And then as it curves up here, becomes more and more opposite to the light source. So it'll get darker and darker. Something like this. And then here, well, it gets closer and closer to the light. So it'll get brighter and brighter. Something like this. And then I can add a little bit of highlights or a little bit of shade here to the front. We'll need the pure white for that edge of the shape here, because this is the edge of the volume that is going to receive the most light, the most direct light, and as a result, it's going to make it the brightest. And so there you go. So I have the face here in the front, which is going to be, facing the light pretty much. So it's going to be a more direct angle. And there we are. So that is going to be it for this chapter. As you can see, now we have a much better understanding at this point, or at least we should have a much greater understanding of how cast shadows work, how to construct them properly, especially with all of these basic shapes. And really, once you're able to do cast shadow, once you're able to draw proper cast shadows for simple shapes like this, it shouldn't be that difficult to really expand that to all other objects, as complex as they might be. So you can always simplify any kind of shape into simpler shapes like spheres, boxes, and cylinders, and things like that. And since we know how to construct the shadows for these, in theory, we should be able to construct shadows for pretty much everything. So of course, the more complex the shape, the more work you'll have to spend to construct a proper shadow. But even as a starting point, it should really, really help. And we also took a look at how the light affects the shading and how to really figure out where the light is going to hit first, and as a result, create the proper shading for our objects. So you can always use this technique, not only to find out how the shadow is going to look like, but to find out how the light is going to impact the surface of the volume and how it's going to go from light to dark. There we are. So that is going to conclude this chapter, and I'll see you in a little bit. In this final chapter, we are going to be coming back to colors once more. So we've seen so far the different properties of colors. We've seen how those properties can be affected when you mix in light into the whole deal. Now, let's take a look at something that's a little bit more usable. So it's past theory. It's something that you can actually start applying directly to your own work, and something that I highly recommend that you start practicing right away. And so this is going to be color harmony, or color palettes, or however you want to call it, the color rules, or there are many names for it. But essentially what this is going to be is a number of recipes that have been around for a very, very long time. And those recipes, the goal of those recipes, those color recipes, is going to produce an aesthetically pleasing result. Now, I like to compare this to recipes, or like a new chef, right? A young chef trying to learn how to cook. And at the very beginning, what happens is that you learn a number of recipes to practice, to master, and then, once you get really, really good at those, then you can kind of branch out on your own and do your own thing and create your own recipes. But at the very beginning, it's very important to have something to test, and this is going to be the perfect starting point. So color harmonies are exactly that. They are that perfect starting point. Now, where does this come from? Who came up with these rules? Who came up with these recipes? What is this, and why do you need this? So starting from the beginning, then, color theory, not really color theory, but those types of color harmonies, they have been around for a very, very long time. So this is something that started to be recognized seriously during the Renaissance period. And over time, things just got more and more refined. And then there are certain harmonies that started to kind of stick around because they just kind of worked. And those are the ones that we find today. So there are many more than these. So this is an awesome tool that I actually highly recommend that you use, and it's free. It's color.adobe.com, and once you enter the website, this is kind of what you'll see here. And this is a tool that allows you to create your own color harmony, your own color palettes, or use some of the most popular ones, some of the most time-tested color harmonies that exist. Those recipes just tend to work. But those recipes, they're just that. They're just recipes, right? So just like
Real recipe is just like a chef learning to put together ingredients and actually create something that is delicious. It's the same here. The recipe on its own means nothing. The execution is absolutely everything. And not only the execution, but the time investment and practice that goes behind it is really what is going to make those recipes turn out great. And to do that properly, there are some things that you should definitely know. The first of those things is going to be understanding the importance of the key color. So what is a key color? Well, the key color is essentially the color that is the most important in whatever piece you're working on. So if you're working on a particular character, and that character you really want like a part of the character to have a very important color, like the color maybe represents its life or its power or something like that. In the case of the Hulk, for example, right? The dominant color, the key color for the Hulk is going to be the green, right? Because that's the color of his skin. That's the color that makes up pretty much the entire character. And so that is going to be the key color in that case. But the key color can differ, and it can represent a number of different things, right? There's no right or wrong, but you just have to know that for these color harmonies to work, you always need to have one key color. If you have two key colors, you can potentially make it work, but you're going to have a hard time, and most likely it's not going to look that great. So what do I mean then by being the most important color? To be the most important color, to be the key color, you have to be more saturated, you have to be brighter, and you have to be more vivid essentially than the other colors. So that would be, that would mean in Photoshop to have everything at 100%, right? So 100% brightness, 100% saturation. So if you have one of those colors that have those properties, then that is most likely the key color in the piece. Of course, your key color doesn't have to be 100% everything. It just has to be more than the other colors that are part of the color palette or the color harmony that you're going for. And the reason for that, your key color is the main actor, right? So you can think of a movie. If you have two main protagonists, it's a weird vibe. They're always fighting for attention, and it just makes things a lot easier. It makes things a lot more comfortable for people when you pick the winner, when you pick the main direction, the main focus, and then when all the other colors that come with that just need to follow, right? And be complement to that color. And so with that, let's take a look at the main ones here that we have and why those work and how you can use them for your own work. So in this case here, in the Adobe Color website, the most basic one is going to be the one called Shades here. So Shades, essentially what it's going to be is just different brightness for the same hue. So the saturation is not going to change. Like we've seen before, right? Shades only impacts the brightness of a color. And so that's going to be essentially there's only one color to choose from, and then the other colors in the palette are going to be automatically kind of selected based on the key color that you choose, and it'll create for you a aesthetically pleasing palette of color. So then back to the shades harmony. So this one, I would not recommend that you use it ever, because it's very limiting is what it is. And usually those colors are not going to give a great result unless it's for a very particular, a very specific purpose. So you might, maybe some types of consumer products, maybe a particular scene in a movie where it's only going to be kind of like, this one scene and then it's over. So if it's temporary, if it's in really, really small doses, that works. But for us CG artists, if we're working on an artwork, this is something that people will have all their attention directed towards, and it's not going to be something that they flip through and to get to something else. It's not going to be something that is just passing. It's usually speaking the end result. It's the destination, right? And so when you want to make a statement, you'll probably want to find something that's a little bit more interesting, a little bit more pleasing to the eye, which is really the whole purpose of these color harmonies. And so moving on then from the shades is monochromatic. So monochromatic is very similar, but the main difference, and what actually makes a big difference here in the resulting palette, is that we are going to be playing with saturation as well. So it's not only shades, it's shades plus saturation. And so as you can see here, the variance that we get here it's a lot better. There's a lot more stuff that we can do with this. And this is a color palette that you will find quite often in films, in various types of art, because it's simple, but it works. And if you want to have a particular piece of art that has a very dominant color, or make a very bold statement about something, as opposed to using just shades, this is going to be much more successful, usually speaking. And so, like I've mentioned before, this case, the key color is going to be, usually speaking, the one that is the most saturated, and with the other colors here kind of taking more of a back seat in this case in terms of saturation and brightness. Now, with that said, this is a color harmony that will only work in some scenarios and not so much in others. So when it comes to character design, like a palette for a character design, so as you can see here on the right, this doesn't really it doesn't really scream at you. It's not something that's super interesting. Even if I were to play with the values a little bit more, so making more some areas brighter than others, it would still kind of be lacking something. It's not that interesting. That might work great, however, for some environment. So let's say in a movie, like a scene in a movie, if you want to convey a particular feeling. So it can definitely work in a number of scenarios, but in our context, in the context of creating art, creating something that people can look at for a while and then move on to something else, this is not going to be something that will want to touch too much, because it's just not that interesting. So if you're trying to convey a very particular feeling, so if you're trying to convey like rage or something like that, then you might want to have a piece that's almost all red, so monochromatic red. But even then, you'll still be very, very restricted by the range of colors that you have at your disposition. So even if that was the goal, you could definitely go for some other ones that we'll see shortly. Because even in the examples that we've seen so far, all the images playing in the back here, they tend to cheat a little bit, so it's never completely monochromatic. So the feel will be, so the image as a whole, if you squint, it will feel kind of just one color, but they always cheat a little bit, add in some slight changes of colors here and there. So yeah, unless you're willing to bend the rules a little bit, and again, they're not really rules, they're more like suggestions, recipes, and you can always tweak them if you want, which is what most people will do. But if you want to stick to a purely monochromatic color palette, you're probably not going to have that great of a result or that great of a time working with that, because it feels really, really restrictive. And it's never a compliment when somebody tells you that your piece feels monochromatic. So it kind of has this negative connotation associated with it. And for that reason, let's take a look at some more that I feel are much more interesting. The next type of color harmony is going to be called complementary colors. And so this is going to be two colors opposite on the color wheel. And so they are always going to come in pair, and this is one of the most popular kind of type of color harmony. It's found everywhere, and it's actually kind of easy to use, which is why you'll see it everywhere. And so you'll find this in film and all kinds of designs, in interior design, it's everywhere. And so the best way to use complementary colors, since they are always going to be in pairs, it's always very important to have the ratio between the two colors be different. There's a lot of scenarios where you'll have actually two colors that are pretty intense. A lot of the times that's going to have to do with lighting. So this is something a lot of movies use. So a cold and a warm light. And so as a result, you'll have kind of like this orange and blue, complementary color combination happening. So this is super common. And the best way that I've found to use it, the best way that I recommend you use it, is always to have one of the colors be, of course, the dominant one, the key color, the dominant one, and having the other color be very, very desaturated. The majority of the examples that I have here actually follow this guideline. The only exceptions that I can think of is going to be when you have kind of kids movies or things that need to be like really fun, or if you have something that's for the general public, like like Christmas is a good example, right? You'll have very saturated greens and very saturated reds. For an artwork, I would never recommend that because it doesn't look that great, especially if you have two primary colors that are very, very saturated. It never works that well because they fight with one another. But in most cases, what you'll find again is one is going to be much more desaturated, almost to the point of being gray. And so now the ease of use for this particular harmony is also kind of one of its negative aspects, in the sense that it's going to be everywhere, this kind of stuff, right? So you don't really need to know much about colors to be able to make this work, as long as you don't go for full saturation on all the colors. But all these color pairs, you'll find them really often. So, the green and the red, the yellow and the blue, the pink and the purple, those are super, super common. And this is the one downside for me, I think, because whenever you use them, it's as if you're using kind of like a cheap trick to make something work. Of course, it's not always the case, but yeah, all of this to say that complementary colors, they work, they always work, and you can find them everywhere. And before I move on to the next one, which I think is a little bit more interesting than complementary colors, just a quick note. When I talk about color palettes or color harmonies, it can be applied to absolutely anything, right? So it doesn't always apply to the entire image. It doesn't always apply to, an object or a character. It can apply to absolutely everything. It just depends on the plan. It depends on the goal for it. So in the case of a movie or a film, well, you'll probably want the color palette to work for your frame as a whole, because that's kind of the format that you're delivering. But in the case of a character concept artist, for example, he's not going to have to worry about the entire frame, right? You're only worrying about your own character. So the color palette in that case is going to be only applied to that character. And so that can be the same for absolutely everything, right? So it can be a color palette for the environment, and a separate color palette for the characters, and then a separate color palette for different objects or the bosses or whatever. So it's not for one thing, it's not fixed. It can be you can use it however you want. So now I said that the complementary colors are a little bit easy to use, and for that reason I'm not a huge fan of them. But there is one variant of complementary colors that I really, really like and I use all the time, and that is going to be called split complementary colors. In this app here, it's going to be called compound colors, but it is exactly the same thing. And what it is just a complementary color, but instead of picking the color right in front, you pick the color right next to that color, so on either side. So for the same blue then in split complementary, you would have the options to go between orange or lime to go along with the blue. So it just gives you a lot more possibilities, and it makes it harder for people to easily pick up on the fact that you're using that particular color harmony or that particular type of palette. So, as opposed to red and green, which is really, really common and everybody knows that combination. If you use red and cyan or red and kind of like this yellow green, well, it makes things a little bit more subtle. And this is definitely my preferred way, my preferred kind of color harmony to use. So I'll use this a whole lot in the exact same way as you would use a just complementary harmony. And so you'll have your key color being the lead and all the other colors kind of following along and just helping support that key color. Now, one thing that I want to mention about key colors, it is that it does not have to be the color that is in the greater ratio. It has nothing to do with that. It's just the one color that for you, for your particular scenario, for your particular case, needs to attract the most attention or command the most attention. So it can be absolutely anything. For example, if you have a painting on a canvas that's just all gray, and then you have one tiny dot of bright blue somewhere, well, the ratio here obviously is not in the favor of the blue dot, but the fact that the blue dot is more saturated, the fact that the blue dot has some sort of rarity compared to everything else, and also the fact that it is completely different than the rest, that alone should be enough to bring most people's attention to it when they see the painting for the first time. And so this is exactly what you want your key color to do. This is the role that it has. So you can go about getting that attention in many different ways. And I just wanted to make sure that, the ratio of color, just because there's more of one color doesn't make that the key color. The key color is something that you decide on, and it's independent of the amount or the quantity that you use. It's all about the relationship with all the surrounding colors instead. All right, so now we have 2 more harmonies to cover, and the next one is going to be the triads. And so triads, essentially, they are going to be a perfect triangle on top of the color wheel, meaning that we'll get a really, really big range of colors. And this is a kind of a double-edged sword in a sense. So you can make really, really good use of that, but it can also really backfire if you don't know what you're doing. So there are really 2 ways that I would recommend you use the triads. The first one would be to have, pretty much like we've seen so far, have the main color, the key color, lead the other 2, and have the other 2 colors be really, really muted. So that they don't compete with one another, and they certainly don't compete with the key color. So this can definitely work, and actually brings a lot of richness, a lot of different colors into the mix. It's a little bit harder to use because you have more colors to play with, kind of just like more ingredients to work with, but can really create some rich color combinations, some rich palettes to work with. So then the second way that I would recommend using the triads would be to desaturate all of them. So not have any one that is more dominant than the other one. So for that, that could be kind of maybe a secondary color palette that you use for other things. So let's say, for example, you have a scene where you have 3 different characters and one character that is the leader, and that character has a white dress, and then maybe the environment that those characters are in is a super muted environment. Maybe it's dark, maybe it's raining outside or something like that, so all the colors are a little bit more desaturated in the scene. So this would be kind of a perfect occasion for the triads here to work. So if you want to bring in touches of colors here without really disrupting everything else, you can definitely desaturate those 3 colors and apply them on different secondary characters or maybe different objects in the scene or things like that to bring in more colors when it's needed. Now, sometimes, having all 3 colors super saturated is going to be a deliberate choice on the part of the artist, and that can be, let's say you have something that needs to look childish or that needs to look like it's chaotic or something like that. There's always ways to use them but use them in not quite the right way, but still make it work. So it all goes back to those harmonies not being rules or anything like that. It's just suggestions, kind of recipes that you can try and tweak if you want. All of this flexibility, all of these options also make the triads a little bit harder to work with if you're not experienced. It's definitely not one color harmony that I would recommend you start playing with right away. Start with something simpler, something that we've seen at the beginning of the list, and keep the triads for a little bit later when you have more experience. And this is something that is going to be really, really fun to work with if you know what you're doing, if you have that experience, but it can really mess things up if you don't use it properly. So then the added complexity also makes it a little bit harder for most people to identify when looking at colors. So there we go. The triads are really fun to work with. That being said, let's move on to the final type of harmony. We're talking about analogous harmony. So this is something that other people might also refer to as related colors, and this is really what it represents. You take your key color and it's going to be the colors right next to that one. So it can be the one color next to it. You can go as far as you want really, but not past kind of like the halfway point of the color wheel. So what's really great about this type of harmony is that it's essentially taking a monochromatic harmony and making it much, much better. So you'll find these types of harmony in a lot of different scenarios, but most of them have to do with being comfortable. So it'll be quite rare to have an action scene or something that is really dynamic, or something that some sort of tension between characters or something like that. and have also analogous harmonies, because analogous harmonies, just the fact that they're all close together, really creates this comfortable mood. And so you'll find analogous harmonies a lot when looking at forests, nature scenes, nature environments, because, of course, the trees are green and then the sun is yellow, and then you'll have maybe a little bit of water here and there. So those are all related colors on the color wheel. They're all next to each other. And so this usually creates kind of this warm, fuzzy feeling. And it really, really works well when trying to convey comfort or warmth. If there was one type of color harmony that I would recommend you to start with, it would be that one. It would be analogous harmonies, because they are kind of easy to start with. You just pick a color and then you pick the colors on either side or on both sides of that initial colors. And it just feels very natural. It's a natural progression regardless of where you are on a chromatic circle. You can always go either left or right to get warmer or to get cooler colors. And so this is what makes this particular harmony work so well, is that on each side, one side is going towards cooler colors and the other side is going towards warmer colors. And so you have really the entire spectrum that you really need when choosing a color palette. Now, there's one thing that's a little bit different in this case, and it's going to have to do with the intensity of the colors that you can create or that you can select here. So one thing that I've noticed personally is that you'll be able to get away with a lot more of saturation mistakes, or not desaturating other colors too much or enough, or having a weaker key color. You'll be able to escape a lot of the usual problems that you would normally have with other types of harmonies. And you can see this a lot in the examples, but you'll often have some very, very saturated reds, some very saturated purples and pinks, all coexisting in the same image. And that's only because they are all bunched together in the chromatic circle. So they never are going to fight head on. You probably know, but if you mix two complementary colors together, you get black. And so they cancel each other out, at least talking about pigment color here. If you mix two complementary colors of light, well, you get pure white. So not having this direct confrontation between colors in your piece or in whatever it is you're working on really makes a big difference, in that you don't really need to rely on that one actor, that lead role, or that key color, because they're all aligned in the same direction, all going towards the same goal together, instead of competing too much. So once again, I would highly recommend that you test this out first, or you can also start with monochromatic if you want. But seeing as analogous harmonies are just a better version of that, this is what I would start with. And just like I've done with my own character, the female character, changing colors there, do the same thing. So create a character of yours, or an environment of yours, or whatever drawing you have that you can apply a color palette on it. Generate them in here in Adobe Color CC, or on your own if you want, using the chromatic circle. And try applying those colors in different saturations, different ratios, on different pieces of your art, to see what works, what doesn't work. Try to see, maybe find patterns of things that work well together while others don't, and experiment. Colors are such a complex part of art. There's so much to cover here that, of course, we are not going to be able to cover everything in this first class, but we have a follow-up class, a second class on color and light theory in the next term. So this is where we'll really dive in and hopefully answer a lot of the questions that are going to come up as you start working on this on your own. So here we are. This is going to wrap up this first class on color and light theory. So once again, practice, and practice makes perfect. So do it, and I'll see you next time.